Last time we talked about how to use combinations or the combinations method to come up with coefficients when we're expanding a binomial. This is the binomial theorem. Today I'm going to show you how to do the same thing using your calculator. So if you have your calculator, what you have to do is the following. To come up with this coefficient, n is 3 and r is equal to 0, you first enter the value for n, so that's going to be 3. Then you go under math, you press the right arrow and go to the probability tab, select option number 3, and now you can put in your r, which in this case is 0, enter, it gives you a 1, which is what we would have gotten from here. Okay? So this first number here, remember yesterday we got a 1. Did we finish this yesterday?
No. Do you have another?
For the second coefficient, n is 3, r is 1. So I put in 3, again, math, the probability tab, pick option number 3, and how much is r? 1. That gives me a 3, which is exactly what I was expecting. Okay? As a shortcut for successive steps, in order to not go through the whole process, you can just do a second enter. It gives you the last thing you entered into the calculator, and all you have to do, because n is staying the same, all you can do is just change the r value. So change it to 2. You get a 3, which is your next coefficient. And if you do it again, second, enter. Now r is going to be 3. You get a 1, which is your last coefficient. Okay, so this is how you can do it on your calculator. Now, I've listed the steps for you here, so you can refer to them if you forget how to do it on your calculator. Let's go to this next example. It asks us to find the coefficient of the indicated term in each expansion. So here we have a minus b to the power of 10, and we want to look for the fourth term. Okay? So what we need is n and r. Okay, so n is equal to 10 because that's the exponent. Now, as far as r, if it's the fourth term, right? So r is the exponent of the second term, of the second variable. So if it starts with, so it's always, for example, it's a to the 10 and b to the 0, right? So the fourth term is going to have b to the what? 3. Okay? So that's your r value. To figure out r then, it's 4 minus 1. R is equal to 3. Okay? Now, the term itself is going to be c. This is n and r. Now we know what n and r are. And it's going to be the first term here, a to the power of n minus r, and then negative b to the power of r. That's the formula that we're going to be using. Okay? So n we now know is 10. So this is 10 and 3. A to the power of n minus r, 10 minus 3 is 7, times negative b to the power of r, which is just 3. This goes in the calculator. For the last problem, we have to expand using the binomial theorem. If this question happens to come up on a test or a quiz, okay, if I have specified that you need to use the binomial theorem, I need to have the proper form for the binomial theorem, meaning I need to have the first step where you've put in all your c's and your variables are raised to the proper exponents. So here's what I need to see. The first situation is c, that's the first coefficient, 5, 0. So this is a 5, 0. And the first term, 2t, is raised to the power of 5, 3u to the power of 0, plus. The next one is going to be c, 5, 1, 2t to the power of 4, 3u to the power of 1, plus c, 5, 2, 2t to the power of 3, 3u to the power of 2. So each time, this is n, this is r. This exponent is n minus r. This one is just r. So you can do it almost without even thinking too much. The next one is c, 5, 3. So it's going to be 2t to the power of 2, 3u to the power of 3, plus c, 5, 4, 2t to the power of 1, 3u to the power of 4. There's one last term, c, 5, 5, 2t to the power of 0, 3u to the power of 5. If I've asked you to expand using the binomial theorem, I must see this step. After this, you can plug in the value for c into your calculator. So in the first case, C50 is 1. Now, I have 2 to the 5, which is 32. T to the 5. This is to the power of 0, so it's 1. It goes away. The next one, this, when you put it in the calculator, it gives you a 5. Now, here I have 2 to the 4, 16, times 3. That's 48. T to the 4, u to the 1. Plus, this number should give you a 10. Times 2 cubed is 8. 3 squared is 9, 72. T to the power of 3, u to the power of 2. Plus, plug this into the calculator, you're going to get a 10. 2 squared is 4. 3 to the power of 3 is 27. 108. T squared u cubed. Plus, this is going to give you a 5. 2 times 3 to the 4 is 162. T times u to the 4. And finally, the last term, this is going to be a 1. 2t to the 0 is another 1. So it's just 3 to the power of 5, 243, u to the 5. Multiply through. This is 32, t to the 5, plus 5 times 48, 240, t to the 4 u, 720, t t cubed u squared, 1080 t squared u cubed, 5 times 162, 810 t u to the 4, 243 u to the 5. And that's the expansion.